while you bring this thing, what it will look like, I'll show. So this is called the virtual box. Yeah, this is called the virtual box software. You have to install it in your Windows machine, Windows 10 or Windows 11, and the link is given here. This is the first link. If you click, this is the latest version, and it will be downloaded and it will be installed. During the install, it needs some pre-installed system support, so software support. Mainly, what I have seen, the error comes like you don't have Microsoft Visual C++ redistributable software. But most of the system, if you do updates and all those things, generally this is present. But during the workshop, what we did in many colleges and many lectures, so, I have seen that is the only error while installing this virtual box. Might get error. If you get that error, you have to install this thing. This is the MSVC++ redistributable software. If you install it, I think you have to restart your machine. After that, you try to install VirtualBox once again, and you will not get any error, and things will be installed. And after installing, if you start, you see this kind of box, this kind of software window. So here, this and after that you have to install the Linux distribution. This is the ISO file, which is basically disk image. Earlier, use CD drive or a DVD drive, and that now it's in the ISO form, the software. Since we have a good amount of storage and internet connection, you can download. It is almost 3 GB file. You can download and save it in your hard disk, Windows hard disk. And this is your Linux disk image, and you have to install this Linux onto this virtual box. How to do that? Initially, when you start, you will not see this X12, all these things. This is a machine already installed for me. So you will see the tools things, and it will be selected. And if you click on this new, that will come up, and you have to go through some of the installation processes to add X12. So if you have any questions on that during the installation, let me know. If you have tried, not able to do, I'll be able to help you today itself. So that this is very important, so that you can get going with your work. So this is the next window. If you press on the new button, name, you can give any name of this machine. Like I have given this X12, this. So this is your Linux machine name, and this is everything is software happening, software machine, but it will be running on your one of the cores or two of the cores of your processor of your laptop, desktop. So it gives a very good performance. This is the like hardware accelerated virtual machine. And you can give any name. ISO image, here is the place you have to select this. This is I have downloaded here, and you have to select this downloaded ISO image. and this is true for anything. So virtual machine works based on your VTX support of your processor. And if you have Windows 10, you can run even another Windows 10 on virtual box, another Windows 11 on virtual box, another Linux, Ubuntu, Linux, Fedora, Linux, Red Hat, anything, SUSE, or Raspberry Pi also, the operating system only. You can run any operating system on this. You can run a Mac operating system on this thing. So this is basically a facility to run another operating system on your existing Windows. And that, if your base, like the main operating system of your laptop or desktop, it is Windows, that is called host operating system. Whatever you install in the virtual box, that is called guest operating system. So the host can be Linux. Suppose if you have a Linux laptop, then you can run install a Windows 10 on that thing through same virtual box. If you have a MacBook, you can install a Linux or another Windows. So anything, any combination is possible. Any operating system can be host, any operating system can be guest. So this is a very wonderful feature, or like arrangement or configuration. Everybody, so those who works in different things, it is very useful. Try this. Even if you continue in this project or not, this is a very good facility. So I have selected the Xubuntu. There is a like normal Ubuntu, which comes if you go to ubuntu.com, there will be Ubuntu. But that Ubuntu, I am not, you can still install that thing, but I am not recommending that, because that is, the graphics is very heavy. The background, the Windows manager, like the graphics, the desktop picture, the look, feeling, it will be like 3D kind of thing, very rich in graphics. The normal Ubuntu, which is there in their website. So that is also fine. There is no problem, but it takes a lot of processor and video memory. And if you don't have a video card, that video memory will come from your RAM. If you don't have video RAM, it will come from the processor RAM. So it tends to slow little bit. But if you have like higher end processors like i3, i5, i7, then you will not see any kind of degradation in performance. But if you have Celeron dual core, Pentium quad core, or Atom quad core, then you will see the performance degradation. So since we will be working mainly on VLSI design on this virtual machine, so we need compute power, not the graphics power. Xubuntu is a Linux distribution which has low-end graphics. Means graphics is not good, so it doesn't take much of the resources. So the whole processor core will be dedicated for your CAD tools, for your like design, simulation, layout, all those things. So that is the reason I have chosen Xubuntu. Um, so this is the thing. But anyway, whatever ISO you have downloaded, you can mention it in this, and make sure, very important, you click this on skip attended installation. That is very important. Otherwise, if you do everything on its own and later after installing, you'll face few issues that I have seen. I have seen just now also. There is like internship program by CAS. I'm mentoring 4 students from NIE. They also got the same problem. They did not check this this box, and after installation there were issues. So make sure this you do very you have to do it. Skip unattended installation. And just for the demo purpose, I have given ABCD hardware. This is the hardware listed that is present in your machine, means desktop or laptop. So take at least 2 GB RAM. Suppose I have 10 GB RAM in my machine, so I can take more. The rule is at least you can take at least half. Like I can take half of my RAM, means 5 GB. If you have 8 GB, you can very comfortably allocate 4 GB for this machine, but not below 2 GB. So 2 GB to your half of the installed RAM of your motherboard. And processors, if you have i3 or like dual core, like quad core, or many things like i7 has 32 cores. So comfortably you can take half of the cores, like 8 cores for i7, maybe i5 you can take 4 cores, but one core is also fine. But if you have the luxury, like I have 4 cores in this machine, I can comfortably take 2 cores, and that will boost my performance. Like my runs, tape out runs, or design runs, simulations, all those things will take half of the time. So that is up to you. Generally, whatever resources you have, the best, the bottom line is like thumb of rule, you can take half of them. Don't enable if EFI, let it be blank. And like this, if you go, and there is a create a virtual disk now, that is fine. And here it is by default 25 GB will come, but you have to make it at least 100 GB, because the output files will be more, and you have to allocate some memory from your this thing. This is not like you can take half of the disk. Anyway, you can take half of your hard disk, but that is not needed. And also it will be this option, see, pre-allocate full size, so it will not be, even if you take half of the hard disk, the whole is not blocked. If it will be blocked whenever your linux grows, that hard disk grows, it will be taken from your main hard disk. So you are safe, you can take anything. And as it grows, it will show like that. And create a virtual disk now. So it will create this thing. This is the configuration, machine name, this is the ISO, and all these things is there. I'll not click on finish, because it will then try to install. So but I want to show say one thing. After you start installing, the normal, if you have seen how to install in your like bare, like first time desktop or laptop, you will, the same thing, same windows will come. It will ask for your location, time zone, keyboard things, everything you can select, or select the default thing that is selected there. Time zone, obviously you can select Kolkata, Chennai, Bombay, that thing, so that it gives you time. And most important things are, there will be 2 or 3 options, like install or try. Just click on install, and after that there will be like erase the whole thing, or add or delete something. Click on erase everything and install. And after that it will ask for that machine's username. So you have to create an user. So create that thing, username and password. Keep the password very simple so that you don't forget it. And that's how it is. So let me know if any of you have tried it and faced any issues. Just let me know. I'll wait for a couple of minutes now. Okay. I'll assume there is no issues. But please, if you still haven't done, haven't installed, just install. Go back from today's webinar and install it. Even if you face any problem, you can DM me, and you connect, join the WhatsApp group of SEDA. The group link is already there with the notice, and from there you can take my WhatsApp thing and DM me personally. I'll be able to guide you. Okay, so let me share my screen once again. So after installing, um, you will get whatever name you have given, that will be listed here like this. So you have to select and start like this here also, or machine show. So if you click on this show, it will start booting. It will start booting for the first time. It might ask to update something. If it asks to update, you can click yes and install. And after updating or whatever, after the machine, like you push the switch on off switch in your laptop or desktop, and your system comes up, the same exact same similar visual you will see, and you will see a window like this. So I will log in to my system, and there will be some options will come, I think. uh, Okay, those options are hidden now. So here the tab, like for any windows like this, the tabs will come here, and there will be one view tab. If you select that, there will be options, scaled mode. If you you should click on that, and then you can like resize your machine size will be smaller or bigger based on your needs. If you do scale mode, and whatever the size of window, your screen will be like that, and there will be no scroll buttons in scroll bars in the bottom or in the side. So that is a usability feature, that is fine. If you don't do also, that is also fine. But scaled mode from view is a good way, like convenient way to work. So this is my Linux machine. After starting your virtual box, installing everything, whenever you start, you do this thing, like that. And after work, this button is like Windows button, and there will be options like this. It's similar but little bit different. And here there is a button, like on off. If you click that, if you do shutdown, your this machine will shut down. Similar exact thing, the circle will round and round, and it will turn off, like that happens in normal desktop or laptop, like that. So I'm not turning it off. A restart button is same, like that. uh, so all these two functionality exactly same for a physical machine, like a physical machine. So I'm canceling that. So most important now is to open this terminal. So from start menu, you will get this terminal thing, and if you click on that, you will get a terminal. This is called terminal, xterm, login prompt, or anything like that. So this is the most important in Linux. Most of the time, you have to work like typing here and enter whatever with all the options and all this. And you have to be very convenient or very conversant working in this terminal. This earlier it used to be called dumb terminal, because it is there is no GUI or anything. Most of the time you'll not see GUI, but nowadays, like Cadence and Synopsys tools, they have GUIs, but still lot of the things has to be done in this black and white window, and you have to know how to this thing. So the operating system here is Linux, but whatever you do, ls means list, then cd change directory. These commands you have to know very well. And what it is called, like when you start a terminal, you will end up in this arrangement is called a shell. And all this ls cd are called shell program. And there is another thing, shell programming. Just learn yourself. We will not be able to teach that thing here, but you have to know shell scripting, shell programming, and all the shell commands like cd, ls, then mkdir is the make directory, how to change directory. Then grep is finding a string inside a file, searching all this thing. Find means finding, searching a file in the directory structure, and many more commands. The more you know, better it is. And these are the pre-installed directories, mostly like Windows. Nowadays Linux is giving a trying to give a look and feel like Windows. So desktop is desktop. What is the here? That is the desktop. then downloads. If you download anything, that will be downloaded here. And this is the Explorer, like Windows. From here also you can traverse the directories, go inside the directories and see what is there, what is not there. But generally speaking, any VLSI design engineer or anybody who works on Linux, they don't even touch this like GUI kind of thing. LS download. This is way how we work. If we want to see any what is there inside the directory, it will be like this. And for my projects, whatever I create, generally I create this directory, projects. So is the words visible, or shall I increase the kind of font? Let me increase, I think. Or okay, I think it is visible. Yes, I can see in another window. I think it's visible, but if it is not visible, let me know. I can increase maybe, or let me increase it right now so that there is no confusion. So this is the edit button. I went to edit preference. The preference window is coming. Then appearance. This is the font. I am using 12 size. Now I will use little bit more, maybe 14. I think this should be fine. Close. Now it is little bigger, I think, and it will be easier to view. So whenever I this is my choice. It is not like, it is not that you have to do the same thing. Whatever I work, I create a directory of projects like that, and inside that projects, my everything, my work is there. So what is there? LS. If I do LS, so what are the directories? Like analog. If I do analog design, it will be in analog. If I do it digital design, then it will be under digital. And these are the other things. CPU, this is designed by me, 16-bit microprocessor. If you see what is there inside this, then LS CPU, it has like CPU, then test bench, uh, powered netlist after tape out, non-powered netlist after tape out, and this is some kind of a wrapper on this thing so that I can send it to some fab, those kind of arrangement. But this is the main IP. So this is CPU. And if I have to show like SPI, this is a SPI protocol. What is there inside SPI? That is the same thing. SPI.B is the main IP. Test bench, um, and this is the wrapper on SPI, so that it takes care of the IO and all those things. So this is how I arrange my work, but it is up to you. There is no hard and fast rule for you. So that is how it works. Now, uh, what are the softwares you need to start working? You need a lot of them, but today I'll show you very basic 4-5 things that you need, and I'll show you how to run them, how to use them today. So first thing, you have to install a few things here. So whenever um, initially you don't have to do this thing, but just have a look. There is something called software updater. I am clicking on it, but you don't have to click on this. It will come like automatically when there is a need, like in Windows. if you need to do update, software update, that pops up in your taskbar or something somewhere there. Similarly, in Linux also, Ubuntu Linux, basically you this pops up, and if it pops up, then only you can do update. Otherwise there is no need to update. But it is a good practice whenever you get this window, like here, it will automatically come here. Now today I have clicked on that, that's why it came up. But generally, if you don't do that, you don't need to do that thing. It will come like after 7 days, 20, 10 days, 20 days. Whenever there is a major update, this button will automatically come. Then you click on that and do the updates here. Let it come. I'll show you what comes here. That is important to work so that your all softwares work perfectly fine.
So how do you
We'll wait.
configure the projects folder, sir? Like the read, write, and execute permissions?
Sorry, can you ask the questions once again?
Yes, sir. So how do you configure the project folder for the read, write, and execute permission?
Uh, Automatically, it will be there. So if you create any directory like mkdir projects, the read, write, execute permissions will be there. So if it is not there, uh, um, so uh, let me show you. Suppose I have created one directory ABCD. If I list it, now ABCD is listed here. So if I do ls minus l long listing, see what is the permission of ABCD? It is a D, means it's a directory, not a file. RWX, read, write, and executable permission is there. This is the first three letters is for me, who is the creator. Second permission, three letters RWX, read, write, X. That is also all the permissions are there for whoever is the group member. Like what are the groups I'm part of? If I do like this, then I am part of this Alok, ADM, CD-ROM, blah blah blah. If any other user in this virtual machine has thus any of this group membership, they will also have this part, this three-letter permission. But who is not me, myself, the creator, or who is not part of any of this group, they have the read permission and executable permission, but not write permission. So who is not part of the group, they cannot modify my file. So that is by default. Whenever you create this thing, and then you create, automatically it is created, and this can be changed by the .cshrc file. That is that you can pull it and see how this default behavior you can change it by some programming, that you can look in the Google.
Yes, sir.
But by
Thank you, sir.
default, this, this is the permissions will be there. And this, when you go to go inside this directory, and if you create another directory, it will inherit the same permissions of its parent directory. If you create another file for say, and see, it will also inherit, the file will also inherit that same thing, and directory also inherit same thing, but file will not inherit same thing. See, this executable permission is not there by default. Okay, So that you have to check. If you want to make this file executable, you have to run this command chmod plus x stand for execution. If you do that, then do ll. Now a has the executable permission x. Here the x permission was not there, but after running this chmod command plus x, the x is added. So if you want to remove the executable permission, minus x, so the x is gone. Suppose if you want to remove write permission, minus w, so the write permission will go. So like see, the w is gone, so people cannot write anything, modify this AA file. Like that it works in Linux.
Understood, sir. Thank you.
Yes, so this is taking some time. Maybe okay, let it do it. So some softwares you have to install to get started. Actually, uh, the first thing is iVerilog. This is the Verilog compiler simulator we have to install. It will, by default it will not be installed like this. Okay, so if you click okay, so now it has come, let me finish it. So by default like after logging in, of starting the machine, it may come, may not come. If it comes, you have to click like this, then the window will come, then you have to click on install now. I'll not do it right now because it is not important for this webinar, but this is a good practice. So iVerilog is like this. This is a Verilog compiler and simulator, and again there is no GUI. Everything is in black and white window. Don't get disheartened. Just work on this, because in industry this is how people work. GUI is there nowadays, but very less. So this is there. So since I am using it for long time, so it is already installed. For demo purpose, I will uninstall it and show you how to install any software on Linux. How to do that actually. So first, since it is installed, I have to remove it first. So how to remove a software that, like, the situation is like that, that you will see first. Sudo is an important command. Sudo means super user. So Linux is a secured system. It's not like Windows. Anything can be installed. Even if you are the like only owner, like this Linux system, this is desktop mode. This is, I am only the user. I am only the creator. Only me. But generally Linux is kind of multi-user system by default. Like Windows is a single user personal computer operating system, so by default it is single user this thing operating system. But in nowadays Windows has also like you can install or add many more users, but that is separate issue. But by default, by nature, Windows is for personal computer, Linux is for distributed computing. So by default Linux, there will be lot of users for a single machine. So security is the at the backbone of Linux operating system. So even if you are the installer, even if you are the first user, owner, anything, if you try to do any installation and remove uninstallation, the operating system will not allow this thing. Just to demo that thing, could not open file, blah blah blah, this thing, unable to acquire this thing, like that. So it is not, it will not allow you to uninstall or install anything. So for that thing, this command you have to add for any removal or addition of software. um, Sudo means super user, then that means you are assuming the administrative permissions or privilege to do this thing, because it will remove or add thing in the kernel of the Linux. So if you do that, still there is a check whether your username is kind of can become super user or not. Do you have that privilege or not? That will be checked from this password. So you have to give the password that you used when the Linux was installing. If I do that thing, password matches, and since I am the only user and I have created that, by default I am a sudo user also, and it will be added. But for any other user, if it is added to this machine, they need to be like added to the sudo user list. Otherwise nobody can, even if you use sudo command, you won't be able to remove or install anything. So this is just a question, capital Y or N. So capital Y means if I press Y, it will be uninstalled. But uninstallation is not the main thing, but I wanted to show. Let it get uninstalled. um, so keep writing your questions in the Q&A, and Vamsi or Girish can stop me if I need to take any questions from the chat box. So removing iVerilog, it is removing, then processing triggers, those all those things will come, and Linux, all kind of unknown, full of all kind of unknown words. So don't worry, you will get to know when once you keep using this. So processing trigger means this iVerilog software is uninstalled, and it, while installing, it has installed many other dependent softwares, and when it is installed, it is like reporting to the kernel that those softwares I don't need anymore. If that software is used by any other things, then it will still be there. If it is not there, no other one is using, then it will say that it is easy to remove the others thing. Those are like Linux details, will not cover here. So it is uninstalled. If it is uninstalled, if I want to run iVerilog, no such file. Okay, iVerilog is not there. Earlier, when I typed, it used, it gave this. That means it is installed, and now it is not installed. So how to install it? The similar command, instead of remove, you have to do install.
Look,
Yeah.
how to set the path of the particular installation. For example, if I want to install iVerilog in a particular directory, how do I do it?
Oh, okay. By sudo, that is not possible.
Hmm.
But if you download Verilog,
Hmm.
um, uh, the source code
Hmm.
and compile it, then in that script there is an option to select your installation directory.
Okay, now in this case, where does it get installed?
Exactly. Very good question. I'll show you this thing. So in Windows, if you see this Windows, there is a C drive, which is where the this thing is installed. That most of us know, like C drive, where the Windows will be installed. For Linux, what is that thing? The root directory. So root directory name is slash. Again, Linux is little bit like weird kind of things. The names, the arrangements, everything. They call it in instead of C colon or something D colon everywhere. Whether you install physically or in virtual machine, this is your root. This is the installation slash. So here there will be lot of directories. Bin is the most of the binaries like executable, whatever we were using. Ls, cd will be there. Libs will be libraries. If you want to create any software and link it, like it will be like there. And dynamic link, static link, everything is there. Many other things are there, like mount. MNT mount means if you want to mount any other devices like that. A lot of this thing. Sbin also have done some examples like now. So the trick is the Iverilog is installed somewhere, and you check Iverilog. Now it is working, so it is installed. So where it is installed, I can show you, but the way you can do it for any installed thing which is working, which Iverilog. If you run this command, it will show where it is installed. Slash, this is the slash, inside that slash usr like user installed softwares. So ls slash user, then after that bin directory. If you do ls, the lot of user installed this thing is there. And if you see I what is installed here. So even if you don't go to this thing, if you run a which Iverlog, like simple commands like ls will be used always, right? Or mkdir, which mkdir, see mkdir is an executable, it is installed in the same area like this. But it is not that always it will be user bin, it could be user s bin or slash bin, whatever. And by default, if you see, if you run this thing echo dollar path, this is the by default the path of this thing. So it will be installed in any of this directory. This path variable by default, it is like this. So it can be installed in any of these directories. That 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 software has some internal setup. They will decide it, but wherever it is installed, if you run which that command, if you go with the show to the path. Okay. Now what else you need? You need another this thing, GTK GTK wave. GTK wave is the visualization of the waveform, and this cannot be black and white because waveform needs to be like visual thing. So this is the software, open source, and it works. Believe me, it works always. It is very good. It is no different from Cadence or the Synopsys or Model Sim, anything, or Quattras. They might have some advanced features, but this is good enough for a VLSI design engineer. And I'll show it today. Uh, this thing. So it is already installed because I'm already working, but the same way, yeah, you have to install like this: sudo apt insta all install, then the software, and you can give multiple names like gvim and tcsh, all will be installed like this. And you can do these things. So you can make a note. You have to install gtkWave, gvim, tcsh, and and tclsh. Tcsh is the shell scripting, tclsh is the tcl scripting. Both are heavily used in VLSI design, so better you install these things. You can take a note. All the participants, you can take a note. At least Iverlog, GTKWave, GVIM, TCSH, TCLSH has to be installed. Python is heavily used, but Python is already installed by default. You don't need to like install it right now, because um, Python version, it is already Python is not there. I think Python 3. Python 3 is already installed. So by default, now it comes with the Linux kernel Python. So you don't need to install Python. This thing. Rest of the things, many things has to be installed, but when it is needed, I will guide you. Currently, today you need not bother about the things, otherwise you'll get used. So these are the basic installation I have. So let me check if I have installed gvim. Sudo apt okay, good. That is why I wanted to show this demo. So gvim is a very common editor. It is used everywhere in every industry. In Intel, Samsung, everybody uses it to design, to write Verilog or write anything, scripts. But it is, see, it is a virtual package. Something is written. So basically, it is has no installation candidate, and it is not installed also. But it gives, Linux gives a suggestion. Suppose if you throw a stone in dark also in Linux, this is the good thing. We'll get some suggestions. What you can, to get gvim, you can install this or install this. Since I have experience, I know this has to be installed, but at least you have some guidance from Linux. So that is the beauty of this thing. So instead of gvim, I have to select this thing and let it install, and I'll show you what it is. Okay, so when I install it, it says it is already the newest version. I installed it, I forgot, but the Linux told me you don't need to install it. It is already there. So what is gvim? Gvim is then a file name. If you do that thing, examples with modulator dot v.
Alok?
So it is a nice editor, and you can write any files here, but you have to learn how to use vi editor, vim editor. So there is something called insert mode, non-insert mode, like that. So if you press I in the keyboard, it will go to insert mode. See, the insert is in the bottom, and you can start writing your design. Module pwm, okay, like this. Escape, then wq, write and quit. So if you come up, so it is there. Do ls, see the new file is there, and try to compile. I verilog, the newly created file. So it is create compiled. It's an empty thing, but it's a valid verilog file. And if you see, when you compile a verilog file successfully, you get this output, a dot out. It was not there. So that is a simple demo of GVim. GVim is a GUI editor where you can create your Verilog file. Now
Alok,
I will, yeah, sure.
there is some question in this chat box, and also someone has raised the hand.
Yes, please go ahead.
Yeah, please ask question. I think someone wanted to ask a question.
Sir, is it better to use Git clone and download the softwares like, say, for example, Xscheme and OpenLane, or do we use sudo apt install and install them, because there might be previous versions for those?
Correct. Excellent question. So for OpenLane, it is advised to download from GitHub. So those are the softwares we'll also use in down the line, and based the creators of those utilities softwares, they will guide if it is better to use from sudo apt, then they will say that run sudo apt, but sometimes they might say that you download it from GitHub. And the third is like, instead of downloading anything, they can give you a container. Container is another kind of virtual machine with everything set, all the whatever is needed, all the software is there installed, all the scripts are there installed, all the environment variable is set, everything like a ready-made garment kind of thing. You can just wear it like that container. So generally OpenLane is used from container, and I'll explain it in later date. So you are right.
Sure.
Sometimes it is better to download from GitHub, and sometimes the latest trend is to download a container.
Sure, sir. So just since you mentioned container, can we integrate Docker in our Xubuntu and run the containers?
Yes, of course.
Thank you, sir.
Okay. And Girish, what is the text question in the chat box?
There was only one question. Sorry, there was only one question here. I think that person asked now, and
Okay,
someone
okay,
has raised the hand, but it could be the same person. I don't find that.
okay,
Okay.
okay. So let me show you how to work, how to start actually. Those OpenLane, that thanks for bringing up. We'll be using OpenLane down the line. You can do it, no problem. But the major portion of this project as a like participant is to create a design. So open lane, you can if you have a design, you can run it. I'll show it definitely, but that is little difficult and many problems will may pop up, which is difficult for students, or maybe difficult for advanced students also. But I'll help in at any stage. But if you have a design and verified, you can show the GTK wave, the waveform, the verification files, and all those things. You can send it to us also. We'll be able to help you in the like tape out. OpenLane is for the tape out thing. We will give full support for OpenLane. But design, that is your major task. So I'll show you a simple design, and how I have done it. There is a lot of other ways to do it also. I would like to see the other ways. Try, just focus on the results, how it is done. There is, it matters also. When time comes, I'll tell you what is the problem, and today I'll touch upon little bit on that. But let me show you a simple thing. So let me go inside my this thing, and PWM. This is the latest IP I have written. I have given this project to many institutes, many people. Nobody could give me the output, but this is very simple. Pulse width modulator. Pulse width modulator is a technique, is a design to modulate the pulse width. The frequency of the clock doesn't change. The time period remains same, but the uptime and downtime, like in digital world, it is all square wave. Like, so sometimes the clock signal is high for some time, then it is low for some time within one time period. So generally, any clock generator will generate a 50%, like 50% time it will be up one value, 50% it will be down value, zero. So that is called half duty cycle or 50% duty cycle. But there are some mechanical devices and electrical devices which needs, which works in a different principle, where we need to deliver not only the clock signal but the power. Suppose a led dimmer. Suppose if we send a led, always a DC current, 1.8 volt, always, so it will glow at a full power. An led generally takes 20 to 30 milliamps, and it will glow to its brightest point. But if we want to dim, what is the way? We have to deliver less power. Less power means, then suppose normally if we connect a battery 1.5 volt to this thing, or 3 volt to led, it will glow full. But if you have to dim in analog way, then you have to create a current regulator with a transistor like BC149, or like that. With a resistor you have to bias, so that the collector current can be regulated by those resistances. So instead of 20 or 30 milliamps, if you give 18 milliamps, 15 milliamps, 10 milliamps, like that, the brightness will little go down, like that. That is the analog way. The other way is to give it is a square wave. So if you give a like 50 like 1 kilohertz signal with 50% duty cycle, so half of the time it will be on, half of the time it will be on, off. But human eye cannot detect that thing. Human eye will see the brightness of led is half. that is called dimming technique of any light, any kind of light. So you can give a like oscillating signal with enough millivolt current. And if you change this duty cycle like from 50%, if you make the duty cycle 80%, means 80% of the time period the signal is up, then brightness will go high. If you make it 20%, then brightness will be very low. And it is very good because you are still supplying 1.8 volt, but you are turning it off and on so fast, the effect is like dimming, but actually it is not dimming. Whenever it is on, it is getting 30 milliamps only, the full power, but it is not on always. So that is where this pulse width modulator circuit works. And also another application is servo motors, where the motor doesn't run continuously. You need a angular movement like 30-degree. So there the motor will move and keep will be there at 30-degree angle if you keep on sending some pulse modulated signal. And that angular movement um, depends on the duty cycle of the square wave. So very important circuit. Still it is like sold. Every industrial automation, every small microcontroller from microchip, NXP, or any other like Broadcom, they all use it, and it sells in a billion pieces as a part of Arduino or RISC-Duino or Raspberry Pi kind of microcontroller or SoCs. So what is the design? This is the design. And let me know if everybody is able to. Okay, I'll come out of that because it doesn't record. See, really, GVim will create a black and white window, and it is very bright, good to use. So this is a simple design, pulse with modulator. So this is the power pins. Don't worry about it. Need not to use power pins. That those things are needed for tape out. If you give the designs as it is, we'll take care of that. I'll modify all those things. Clock in is the input clock signal. Clock out is the output. Pulse modulated output. And you need a few things. Chip select means selecting this IP. Whenever you select, then only you will the pulse width will change. And what is there? We are using 3 registers of 3 bit and 2 wires. Count one uptime. Here is the logic, and here is the main logic. There is a counter. If the count is 1, like all the bits, any of the bits is 1 or something, then you load the uptime. Uptime means is the value, like how much time you want that signal to be up. That is mentioned in an input like this. Uptime is the input. You have to tell the circuit what is the duty cycle you want. Based on that, there is a logic, and this is the output, clock out. So how many lines? Total 54 lines. And it is used billions parts. But maybe I have some experience. I was able to do it in 54 lines. Maybe it can take 100 lines, 150 lines for you guys, but not more than that. So I am asking all the participants, start simple things, and you can submit. And if it, we will see if it works, then your design is selected, because it is not that it is a project, it is used in currently in the market in sales. It has a commercial value, these circuits also. And believe me, most of the students could not design it, these 54 lines of code. So just give it a try, give it a try and give it to me. You can do many things like this. So what is the logic, we will never discuss, or in this contest, that is up to you. You will not get any, you will get some training, maybe one webinar will be dedicated for possible, from suggestion from SEDA, that what are the hardwares you can target. And there will be some discussions, maybe in 1-2 hours we will cover 5 to 10 IPs, and that much you will get to know. But there won't be any detailed training on how to write a PWM or VGA, HDMI protocol, a VGA protocol, or anything like that. No, that is your job. That is why you will be paid 10,000 per team, like that. So that is the idea. But this I wanted to show that don't worry, simple things is important. Simple things can be simple, but can be important also. It can sold at a high volume, and it has a commercial value. That's why it has a value. So it is not that always you have to do AI ML chips or i9 i3 Intel processor, superscalar, cache coherence, caching, and all those multi-core. Don't think even about that. None of us, not me also. I cannot design i3. It is not possible. So what is possible, just target that, and it has a value. So how to compile this thing? PWM, this is compiles, no error messages, so it is okay. So what is else there? You need a test bench to test, because if you see the PWM code, there is no stimulus, only input output. But if you don't stimulate, don't give inputs outputs values, it will not simulate. See, a dot out has created. If I run it, nothing, no output is coming out. That's why you need a test bench always for any design. That is the arrangement, that is the infrastructure you have to create, your design and your test bench. And this is a small design that it fit. That's why I chose it to be only one file, but a design can be multi-file also. Then you have to, instead of like PWM, if your design spreads in multiple file, all the files should be listed after iVerilog to get a like successful compilation. And this is the test bench. See, module test bench, and test bench doesn't have any input output, any ports. And you have to instantiate DUT, design under test, where I have instantiated here. This is the my module name, this is the instance name, and the port list of PWM, and the connections, this signal to the test bench signals. I have defined all these signals here, and I am displaying this. I am monitoring each of the input and output, and I am driving it in this initial block, so that whatever I wanted to test, it should test. And it shows that yes, the IP works. And you have to for sure send this file to us also, to prove that yes, all the functionality of your chip is works. And how to do that? This is a VCD dump. I'll show you what it does. Just check it, what is VCD. This is the test bench. I have already written it, so I will compile now with the same iVerilog test bench. So now it is giving one error, missing PWM referenced one time. These modules were missing because this test bench used PWM that instance, but I did not tell that where it is written. So the way to tell it, I have to tell that it's inside that. When I compile two files together, there is no problem. So after that thing, again the same awa.out is created. This is the output simulator from iVerilog. Just remember, output simulator comes around as a.out. Here I ran a.out, nothing came out. See, no output. But if I run, if I compile test bench and design together, design under test together, then if I run out, then it is simulated. See, this is the text simulation. Again, it is possible to work in black and white window, and from this output, one can understand. But obviously, it is little difficult to check the functionality from this text output, but it is possible. That's why the open source community has given another wonderful software, GTK Wave, and after running this a.out, see, another file is created, pcm.vcd. The test bench is written like that, so that this vcd file is created. This vcd file um, will be used for this thing. You have to load that VCD in GTK Wave. This is the way, GTK Wave, then VCD file. So this is the test bench we took. We will load RS. If you select a signal and double click, it will come here in the signals, that pan, then clock, then enable, then this is the PW, and this is the output. So click on the square button and your simulation will be like this. See, this is the input clock and this is the reset we got. So initially this, sorry. So at the beginning, if I see, this is the way. So RS, so cursor marker as 0 second, reset is 0. If I click the next arrow, after 5 seconds, I make the circuit reset. You have to do reset because all these designs are created with flip-flop, and flip-flop, if you don't reset, it remains in uninitialized state, unknown state, that can give you wrong results. And so reset signal is there. So after that, everything got reset. And see, before reset, whatever, like when RS at the beginning 0, RS was 0, no reset. See, PWM out was X, unknown. So that's why when we do reset, see, PWM out has got a definite value, and after reset is off, then the circuit starts working. And enable is one, that's where the enable this uptime, the value is it gets in. That is a technique. So if you enable only, then only your circuit will work. Then enabled, this value is latched into this register, and it says that one cycle it should be up. And see, only one cycle the signal is up, rest of the cycles it is down. After that, see, after sometimes again I made enable high and put another value 2. Then after that, see, this is the signal. It is for 2 cycles it is up, rest of the 6 cycles it is down. And if I
Alok, your
go
voice is
here,
breaking actually.
again I made enable high here, and the PWM output is up for 3 cycle and down for 5 cycle. Okay, okay, okay. What I was saying, so this enable signal, whenever enable is high, I can change the duty cycle value, and uptime is the register where I save this thing. So here I made it 1. That means the 1 cycle the duty, it will, this PWM output will be 1, so it is up for 1 cycle only. Then again, after some time, I made it 2. I made the enable signal high and changed the value of duty cycle. That means 10 means 2, it should be up for 2 cycles. So see, the in the earlier output was very small, now duty cycle is little bit increased, it is up for 2 cycles. If you see, the another time I have done, it is I have enabled enable signal is high, and I have made it 3. And after this this thing, see, this from this time, the uptime is 3 cycle, downtime is 5 cycle, so duty cycle is increased. So again I can make the enable signal high and change the value. I can increase, decrease. That's how the pulse width modulated output will be modulated. So if I bring it in the same one frame, see, initially started with one out of 8 duty cycle. Next I change it 2 out of 8. Then here it is 3 out of 8. So that is the PWM circuit. It changes the duty cycle, not the frequency. The frequency is same from here to here, it is same. For this changed also here to here, the time period is same, but uptime and downtime is fixed. So this is the whole way you have to design. You have to create your if you have to create your design, that is the most important. Also you have to create test bench to prove that yes, whatever you are claiming, that works. So that's what I wanted to cover today, get you started. And you keep doing that thing. Whenever you are ready, you say that okay, my design is working, then you can submit and take part into the contest in the prize money. And little bit of help will always be there, that will do. But as I told, like, will not be able to train you onto how to code Verilog. That will be too much for us. And but you give it a try, and little bit of help here and there, that we can do, conceptualize. But never ask like, I have got a syntax error, sir, this is not working, I'm getting errors. All the errors and debugging you have to do. We don't have any time for debugging any others design. Conceptually, like whether I should use it as a latch or as a flip flop, or where should I do a combinational, those like conceptualized design decision kind of things, obviously will be able to help. But since we are giving a lot of prize money, it is expected that you put your brain. So we have have almost come to the end of the presentation and open for any questions, any kind of discussions.
Alok, just wanted to ask you, even if we code in VHDL, the steps remain same, right?
Yes, step remains same, but will not accept VHDL code because all these tape outs and all these things that has to happen in Verilog.
Okay.
And iVerilog is a Verilog only compiler simulator. There
Oh,
is no open source, good open source VHDL compiler and simulator.
okay. But what students have to deliver is the GDS file, right?
Ha, good questions, Girish. So if they want, I can get them started on how to harden or tape out in OpenLAN. If they find it that is too much, they can give us the good design also. No problem. Because on top of that also, suppose if I show you SPI protocol. See, here is SPI, the design, the test bench. Also, this file is needed. This file is needed for tape out. This is a wrapper that has to be created, and that is nothing like great thing. So the participants should not spend time on this thing, and it doesn't take much time for me. So mostly this packaging I will be doing. I have to do it, otherwise they have to learn the scenario, why I am doing this thing, what is this wrapper, why we need wrappers, which is not very productive or helpful for them. And this is for a particular fab. If the fab change, like if we change from TSMC to global foundry, this will also change, but this test bench and SPI, they don't change. So I am expecting this design and test bench bare minimum. But if anybody is interested, what is this, I can cover in a separate thing, and I can show them how to tape out end to end. So let me see. So my presentation is over. That's why I'm not sharing. So it's UKKG. So, but we can spend few more minutes, or at most 10-15 minutes to answer any of your questions.
Sir, is the project is individual or a group, sir?
Group, but if anyone wants to go along, because this is significant work. um, so if one can, a single person can be group, or 3-4 person can also be group, not more than that. So sometimes what happen, no, people join in group, nobody works, only one guy works, other guys only copies and also shares the money. But if one sees that, okay, there is no point in taking my friends with me, just come along. One person can become a team. But if you see that seriously, there are your friends are really helpful, and you can divide it, like one guy design, one guy do the test bench. Whatever you do, give it to him, he is modifying test bench and verifying. So that is a great help, right? So take those kind of partners, otherwise don't take. Maximum
But can
3 to 4
CSC
percent.
also,
Sorry, yeah, please go ahead.
can CSC students also participate, sir?
Yes, yes, of course. You have to be
Thank you, sir.
IEEE member and SEDA member, and SEDA membership is $0. So it should, if you are a IEEE member, just add a SEDA membership, no payment, and then you are good to go.
Thank you, sir.
Hello, thanks for the presentation. I have to leave now. I'll see you next
Yes,
week.
Girish.
Yeah.
Yeah, we'll also close, but a little bit I'll wait for any further questions. But yes, thanks, Girish. Thanks for joining.
Yeah. 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 Thanks. Yeah.
So
Yes.
I was just curious, like, as students, how do we learn and get to know about what are the different IPs and what is there in the market, and how do we know that if we want to design a particular IP, as you mentioned, pulse width modulator, then how do we know what are the different specifications that the industry requires and the different ways in which we can
Uh,
explore different ICs?
Ah, good question. So for a particular IP, so I'd say like just read the specification of Arduino or any ST microelectronics processor like STM8, STM16, STM32, like that. But Arduino is the most popular do-it-yourself kit. um, Design any of the IPs there. You will see the list of what is there. There is a DAC, digital to analog converter. There is ADC, A to D converter. There is a like timer circuits. There is PWM circuit. And there are SPI protocols, universal asynchronous receiver transmitter, UART, VGA output, like that. So all any of those protocols or all those subsystems are good for this project. And if you take a particular for SPI, then go and search in the Google the specifications and try to understand what it does. And you can see each protocol has some basic core functionality, and after that nice to have fancy things. You don't have to do the fancy thing, only the core protocol. If you design or core functionality, and that should be fine. And later I will cover, as I told, in a next week it will be like this kind of installation for analog side. What are the tools you need? What are the Somebody will talk about a little bit of how ADC design look like, or how sorry, op amp look like. Those will be covered in the next, maybe next to next. I'll take a session on all those like simple but important protocol. I'll take, but you don't have to wait for that webinar. You just look at what is available in as a spec of Arduino, and take any of the subsystem of Arduino microcontroller or Arduino SoC, and you can take the analog IP also, digital IP also.
Sure, sir.
In analog, yeah, in analog like temperature sensor, ADC, DAC, op amp. Those are the common, simple but very important IPs. You can design that also. In digital, generally UART, SPI, I square C, PWM, then VGA, HDMI, USB, then Ethernet. All those things are important. And also this, there is another dimension, memory. You can design simple memories 8 KB, 4 KB, 2 KB, 32 KB memory with 8-bit word, 16-bit word, and the memories can also be digital, also analog. By analog side means 60 cells. You can design that thing, but design a big memory so that it can be usable. So, and in this project we can manufacture memories also for your information.
Hello, sir.
Yes.
Yes, sir. I was working on the project to develop a UART module in VHDLs for serial communication between devices, sir. And I have
Okay.
completed the simulation of the waveforms using cadence tools, which was the, as you mentioned, it was a container. It only has
Uh-huh.
limited tools, Virtuoso and NC Launch. But I want to access for Genus for synthesis. Which open source tools can you suggest, sir, to
uh,
synthesis?
we will be using so the same design. You can do it in iVerilog and test it, so you'll be sure that it is still working here in this environment,
Okay,
and
sir.
like this what I have shown today. And for synthesis you can use eosis. I'll type it here. Eosis will be also using eosis, so you can check their website, and they have sample scripts how to run. So
Can you
you
repeat
can
that?
use this. I'll type it.
Okay, sir. And I have another doubt, sir. Can we install these softwares in that container so that I could work simultaneously with this softwares and your software, sir?
No, that is the containers limitation. Container means like ready made,
Okay,
you cannot alter. So in container it is possible, but don't do it. The other functionality will be also screwed up.
yeah.
That needs a lot of expertise. Yeah.
What if you try to add PDK files in that container?
So everything will be there, otherwise don't use. Like here, we will give you container with PDK, so
Okay.
everything is set. So if any container is not set, it is very difficult to make an attempt.
Yes, sir. Okay, sir. Thank you.
And also one more thing, since you so there is some difference in coding for FPGA and coding for ASICs. So what we are doing here is we are will be target for ASIC fabrication. In FPGA it is liberal, anything can be achieved. So mainly if you have noticed my design, there is nothing like if this greater than this, less than this, and something equals to 1 tick b0, something equals to 1 tick 5. So those kind of assignments will not work. You have to achieve the same comparison by hardware only. Always think that if what code you are writing, it can, what is the equivalent of gates, what gates will be instantiated, like that. That is the this thing. Later in some day I'll show that thing. So FPGA code may not work in this setup. That thing I'll guide. No problem. So any other questions?
Hello, sir.
Yes.
Sir, is it mandatory that all the group members must be IEEE members?
Yes.
Okay, sir.
We are putting effort uh, for yes, giving back to society. That is our motto. And but still we need to increase the membership of IEEE also. That is another thing in the back of our mind also. So we are giving something, we want to get something. As a voluntary work, we cannot charge money, because otherwise this program, even if you pay money, not, you will not get anywhere. No company can give it. But what in return, what we are saying this, become member of IEEE more and more, associate with us, work with us, and do the things what the world is doing. Even though, if they are great guys, but not IEEE member, um, don't don't add them as a team member. Will not allow. So can we then close it for today? Okay. Thanks everyone for attending, and those who has registered today need not to register